So today we're going to talk about expanding and condensing logarithmic expressions. So we're just going to be expanding and condensing logs, which you'll see how to do that. But first I want you guys to do the do now, which is 1, 2, 3, 4, 5, and 6. They're going to lead into how we expand and condense, and it's going to make much more sense. So go ahead, pause the video, and do those 6. So if you look at number 1, we're simplifying the expression x to the third times x to the 7th. What do we do to the exponents if we're multiplying with the same base? That's when you want to add the exponents, so that would be x to the 3 plus 7, which is x to the 10th. So that's how you would simplify the first one. The second one, what do you do to the exponents when you're dividing with the same base? You would subtract the exponents. So that would be x to the 30 minus 10. And you would get x to the 20th. And what do you do when you have a power to a power, so an exponent to an exponent? That's when you multiply the exponents. So that is x to the 48th. So that's how you would simplify 1, 2, and 3. And those are going to come back today when we're expanding and condensing logarithmic expressions. So solve each of the following equations for 4, 5, and 6. So when I look at number 4, it's in log form. Let's put that into exponential form and see if we can do anything after that. We might not be able to. It's just, trying to solve it. So that would be 4 to the third, because our base is 4, our exponents, what the log is equal to, equals x plus 15. 4 to the third, let's simplify that to 64, equals x plus 15. I want to get my x by itself, so I'm going to subtract 15 on both sides. And when you do that, you should get x equal to 49. And number 5, very similar question, just with a common log this time. Remember when there is no base shown on the log, it's really base 10. You can write there if you want to. So that would be our base is 10. Our exponent's what the log is equal to, which is 2. And our argument is x minus 5. So when I simplify that, that would be 100 equals x minus 5. Add 5 to both sides. You'll get x is equal to 105. So that is 1 through 5. Let's take a look at number 6. Number 6... you should probably, if you did number 6, I'd be very surprised. You can't do number 6 yet. The reason why I'm showing you number 6, is that's what we're gonna be learning when we expand and condense logarithms. So condensing, in this case, condensing means kind of like making smaller. So if you look at 6, you see how we have 2 logarithms on the left side here. We're gonna want to condense that. We're going to want to condense that into one logarithm, and then it's going to be much easier to solve. So that's what we're learning today. We're learning how to condense that multiple logarithms into one logarithm, and that's going to help us solve logarithmic equations, which is going to be down the road. So today, what we're doing is what you should be able to do by the end of the day is you should be able to completely expand logarithmic expressions, and also you should be able to completely condense logarithmic expressions into one logarithm. You see number 6. Number 6 is the where we'd be condensing. So I want you guys to go to the next page. So I want you guys to take like a minute and try to expand x to the 8 plus 3 into a product of 2 bases, and then do the a to the b plus c. Pause the video if you haven't. So if I were to expand x to the 8 plus 3 into a product with two bases, not just one, so we don't want x to the 11th, 8 plus 3 is 11, that would be x to the 8th times x to the 3rd. And how about if we did a to the b plus c? Well, very similarly, that would be a to the b times a to the c. Now, these are important to know because logarithms are the inverse operations to exponentials. Therefore, you would do the opposite of what you're doing above. So, I know when we're multiplying with the same base, we add the exponents. When we add the exponents, but when we're with a logarithm, when we're taking a logarithm of the same base, so logarithm of 10, and our argument is 12 times x, we can expand this out into multiple logarithms, so it would be log. So we'd have two logs now, and it'd be log of 12 plus log of x. So it's kind of like the opposite of what we did with exponentials. And why are we doing this? You're going to see it's going to help us solve logarithmic equations. Once we get really good at this, it's going to make the logarithmic equations much, much easier. So I'm going to do I'm going to do number 1 with you guys, and then I want you guys to do 2 and 3. So number 1. If I wanted to expand log of 6 times 7 into 2 logs, well, since we're multiplying, we can separate it into 2 logs that are adding. So it'll be log of 6 plus log of 7. I want you guys to take like 2 to 3 minutes. Try number 2 and 3. So what you should get for 2 and 3. You should get 2 plus log 3 of a. And you might be thinking, oh, Mr. Shannon, I got the log base 3 of 9 plus log base 3 of a. But remember, log base 3 of 9 is equal to 2. So when you simplify that, that would be 2 plus log base 3 of a. And number 3, we have 3 things getting multiplied, 3 factors on the inside of that natural log. So it would be ln of 7 plus ln of c plus ln of d. So we'd be adding 3 different natural logs there instead of just 2, like we did number 1 in the example. So if you scroll down to the bottom of the page, how would you expand? We're going to do the same exact thing, but now it's going to be logging and dividing 2 values. I want to see if you guys can see what we're going to do. Very similar again to the laws for exponents. So do the top 2 questions here. Pause the video if you haven't. So how would you expand x to the 8 minus 3 into a quotient with 2 bases? Well, when we're dividing with the same base, that's when we subtract the exponents. So that's what's happening here. We're subtracting the exponents. So that would really be, if we're using 2 bases in a quotient, it'd be x to the 8 divided by x to the 3rd. You would subtract the exponents, 8 minus 3, to get x to the 5th. And how about just a general a to the b minus c? Well, that would be a to the b divided by a to the c. And once again, remember, logarithms are the inverse operations to exponentials. Therefore, you would do the opposite of what you're doing above for logarithms. So if you expand the following expressions into an expression with multiple logarithms, we're dividing on the inside of that logarithm. So we're going to break it up into 2 logarithms that are being subtracted. So this would be log of x minus log of 5. And I'll do number 1 with you guys, and then you guys can do 2 and 3. So number 1 has log base 9, and we're dividing 4 over x. So that would just be 2 logs that are being subtracted. So it'd be log base 9 of 4 minus log base 9 of x. And we can't simplify either of those logarithms further, so we would just leave it like that. So I want you guys to pause the video and do 2 and 3. So number 2, natural log of g divided by 10. We would split it up into 2 logarithms that are being subtracted, so that would be ln. Make sure you keep the same log there, so it would be ln of g minus ln of 10. Can I simplify anything there? No. You could also write it like this if you want to, ln g minus ln of 10. I just sometimes write the parentheses over the argument. And number 3 would be log of g. We're dividing, so it'll be minus log of 10. Now this can be simplified a little bit more. Remember, log of 10, if you remember the rules, or you can write down its exponential form if you forgot the rules. That would be the base on log is 10, the exponent we don't know is x, and then that is equal to our argument, which is 10. So what power would 10 have to be in order to equal 10? Well, that would be the first power, so that would equal 1. So it would be log of g minus 1. So that would be our final answer for 3. So let's go to the next page. So this is the third property of logarithms that we're going over today, and the last one. So I want you guys to do the top 2 questions like we did before. Pause the video if you haven't. So if I were to simplify this time, x to the 9th to the 2nd, what would you do? We did this property in the do now. You would multiply the exponents. So that would be x to the 9th times 2, which is x to the 18th. But the big thing there is we're multiplying the exponents. And how about a to the b c? That would just be a to the bc. So you can reference this property to understand the power rule for logarithms. So if I were to completely expand log of x squared, what you would do there, it does involve multiplication. So you would take the exponent, which is 2, and just bring it out to the front. So it would be multiplying 2 by the log of x. So that would be log of x squared completely expanded, 2 times log of x. So I'll do number 1, and then you guys can try 2 and 3. So number 1, ln of 7, ln of w to the 7th. You just bring that exponent out front and multiply it, so it'll be 7 ln of w would be that natural log completely expanded. I want you guys to take a minute or 2 and try 2 and 3. So, number 2. Well, that exponent with the x is not shown, but remember a square root, I'm going to rewrite that. That'd be log base 7 of x to the 1/2. So, now since we have that exponent, I'm going to bring it out front to completely expand my logarithm here. So that would be 1/2 log base 7 of x. And that would be my completely expanded final answer. Now let's do number 3. So number 3 is a little bit different than the past couple because there's a couple things going on in number 3. So it's log of log of 9 times x squared. So the first thing you want to do here is what's happening to the entire argument. What's happening to the entire argument is that 2. So I'm going to bring that 2 out in front first. So now this would be 2 times log of 9x. Okay. It's not completely expanded yet. What can we do when we have a log or our argument being 2 things that are being multiplied, 2 values being multiplied together? Well, we can split this up into 2 logs that are being added together. So that would be log or sorry, 2 times log of 9 plus log of x. And then just take it one more step, distribute that 2 back in there so it's completely expanded. So that would be 2 log 9 plus 2 log x for your final answer. So that's 2 log 9 plus 2 log x. And when we expand logarithms, there's going to be a lot of different rules that we have to use to expand them. So the past 3 rules we're going to be using a lot to expand them. So if you guys look at the putting all the rules together, these two, we'll go over these two together, and then I'll have you guys try the a couple of 5 of them on the next page. But so putting all the rules together, let's take a look at this. So the number 1, log of x squared divided by y. So there's 2 things that are happening here. The x is being squared, and it's also the logarithm of a value divided by a value. So if you look at this, the whole entire argument is not getting squared. Only the x is. So we're not going to want to bring the 2 out the very first thing we want to do, because it's not happening to the entire argument. What you're going to want to do first is you're going to want to split this up into 2 logarithms that are being subtracted. So that would be log of x squared minus log of y. If you would brought the 2 out first and made it 2, let's do that. Let's pretend like you did this. It would be 2 log of x over y. Oops, that's a 4. There, it's a y. Then that would be considering that y would also be getting squared when it's only the x. So you don't want to do that first, because then you would have a completely different logarithm that you'd be expanding. So let me erase that. So now we still have to do one more thing, that log of x squared. We have to expand that, so we have to bring that exponent out. So that would be 2 log of x minus log of y. And that would be the completely expanded equivalent way of writing log of x squared divided by y. And number 2, feel free if you want to try number 2 if you want to try before we go over it. So you can try for a couple minutes. Feel free. I'm just gonna get right into it right now. So I'm looking at it. So log base b of 2h divided by 5 k to the 9th. That whole argument is not being raised to a power. So what I'm gonna do first is it's being divided 2h is being divided by 5k to the 9th. So I am going to first write it as 2 logs being subtracted. So that would be log base b of 2h minus log base b of 5k to the 9th. Now is when we're going to split up each of those individual logs, because now when we look at each of the logs, we have a 2 values being multiplied on the inside of them. So what I would do first is I would take that log base b of 2h, and I would write it so it's the 2 logs. So that would be log base b of 2 plus log base b of h. And I'm going to do the same exact thing with that second part. So that would be minus log base b of 5 plus log base b of k to the 9th. So, but there's one thing I want you guys to do before we go on, because this is not correct yet. Because think about when you would, add something like, 2 plus 3 minus 1 plus 5. You would do the 2 plus 3 first, then you would subtract 1, and then you would add 5. But that is not what we're doing here, because this is in the numerator, and this is in the denominator. So in order to separate that and say we know that this is the numerator and this is the denominator, we're going to use parentheses for that. So the way I'm going to write this is I'm just going to insert the parentheses for the entire numerator, which would be here, and the entire denominator, which would be here. So that's telling me we have to do the numerator first, and do the denominator first before we subtract any of the logarithms. So we are not done yet. We have to keep going. So I can't do anything with the 2 logarithms in the first parentheses. So that would be log base b of 2 plus log base b of h. And then I can't expand that first log in the second parenthesis, so log base b of 5, that's done. But that last one, I can bring that 9 out front, so that would be 9 log base b of k. Let's check, can I expand any of those logs anymore? I cannot, so that is my completely expanded logarithmic expression. So let's go to the next page. So this is the last one I want to do together, and then I'm going to have you guys do the checkpoint, which is the next 5 questions. So let's completely expand this logarithm. So the first thing we're going to want to do, think about what the first thing we're going to do is for a second. If the whole entire argument here is getting raised to the second power, that means we can bring that 2 out first. So I'm going to rewrite this as 2 log of b of 3 rad x times y. So from here, you can do one of 2 things. I'm going to go the cautious step and do one extra step that a lot of you guys might not do. That radical x, I'm going to turn that into an exponent, just so we can see what we would do a little bit easier, since it's our first day of doing this. So that would be 2 log b of 3 x to the 1/2 y. So from here, we can see our argument, we're multiplying 3 different factors. So when we're multiplying, we can write it as multiple logs that are being added together. So that could be 2 log base b of 3 plus, I'm going to pull out that 1/2 out in front of the x all in one step here, 1/2 log base b of x. And then the last factor is the y, so plus, plus log base b of y. And the last step would just be to multiply that 2 into all of the logs. So that would be 2 log base b of 3 plus, make sure you distribute to every single log here. 2 times 1/2 would just be 1. So that would just be log base b of x plus 2 log base b of y. Can't do anything else there. That's completely expanded. So that is my final answer. So what I want you guys to do now is take about 10 minutes. You might need less than that. Maybe 10's probably too much. 5 to 10 minutes, and completely expand these 5 logarithms. And if you need extra sheet of paper, feel free to get a loose leaf sheet of paper for this. Pause the video and play it when you're done. And I'm going to show you all of the answers once you press play. So let's look at the first three. The first thing I did for number 1, well, it's 8 times e to the third on the inside of with the argument, it's on the inside of the log. The whole thing's not getting raised to the third power, so I added the logs together, and then after that, I brought that, since the 3 is only the exponent on the e, I brought that out to the outside, so it would be log of 8 plus 3 log of e. Number 2, no powers here, don't have to worry about that. It's just x divided by 1,000 on the inside, so it'll be log of x minus log of 1,000, but log of 1,000, simplify that, that would be 3, so it'll be log x minus 3. And number 3, first thing I did there, I kind of did 2 steps in one. I made the cube root as 1 to the third, the exponent, and then I also added the 3 natural logs, so ln of 3 plus ln of x to the 9th plus ln of y to the 1/3. And then you just got to do one more step after that. You have to bring all those exponents out in the front. So that 9 goes in the front of ln x, and that 1/3 goes out in the front of ln y, and that's why those are there. So that's 1, 2, and 3. Now 4 and 5 involved a lot of steps, so let's take a look at 4 and 5. So number 4, the very first thing I did for number 4, if you see that first exponent, depending on how you look at it, it could be the second also, but the exponent on the outside of everything, the whole argument's getting raised to the second power, so that's why I brought that 2 out in front first. And now we just have 4 f to the second over m as our argument. So I did, it's 4 times f to the second divided by m. So it would be log base 11 of 4 plus log base of 11 f to the second minus m. Now why don't I need another set of parentheses? If I wanted to put another set of parentheses here, I could have, I know I kind of went off the log, I could have, but according to PEMDAS, you would add first, so we'd actually do these first 2 anyways, which would give you the numerator, so you don't need an extra set of parentheses here. You could do it though, that's completely fine, you could do that if you want to. And then I want to bring, okay, so this log's good, this log, I gotta bring that 2 out in front, this log's good, so I brought the 2 out in front here, and then the last step is you just gotta distribute this 2 on the outside into every single log. Oh, and look at that, I forgot to distribute that 2 to that last log. Be careful, it's so easy to do. So that would be minus 2 log m. And let me change that. It is not log m, it is log base 11 of m. So that should be number 4. And number 5, the first thing I did was I wrote that 4th root as an exponent, so to the 1/4. Now the whole entire argument's being raised to the 1/4, so that's why you want to bring it out. Bring that out. And now we're left with just the argument on the inside. We're dividing, so it'll be x squared minus log base b of 16y. Make sure that 1/4 stays out in front the whole time until the very end when you distribute it in. So I decided I didn't bring the 2 out yet. I kept it log base b of x squared, but log base b of 16y, we can split that up into 2 logs, but make sure you write this one with parentheses here. If you don't, you're going to do log base b of x squared minus log base b of 16 first, which is essentially doing x squared divided by 16, which is happening, but then you're going to multiply it by y, which is going to be on, which would put that y in the numerator. So you want to make sure you have those parentheses. Let me outline them again. These are crucial to have here. If you don't have that, It's going to simplify. It's going to condense into a different logarithm than shown above. So now we want to bring that 2 out in front, which I did here. And we're good until we just have to bring that 1/4 in and distribute it into every single logarithm. So I distributed it in here, and I distributed it inside of the logarithms here. So that would be my answer. That's 1 through 5. That's a checkpoint. So let's go to the next page. The last part of these notes, instead of expanding logarithms, so writing one logarithm as multiple logarithms, we are going to condense it. So we're going to take multiple logarithms and try and write them as one logarithm. So it's just exactly what we just did in reverse. So if you're good with expanding, you're going to be good with condensing. So I want you guys to actually take a second. I don't want to say anything about the first one. Try and do that first one. Pause the video if you haven't. So, remember, they have to be logarithms of the same base. They do have the same base. They're log, the common log, which is log base 10. So if we have 2 logarithms with the same base and we're adding them, we can multiply their arguments. So that would be log of 5p. And that's condensed into, we're taking 2 logarithms and condensing them into 1 logarithm. The second one, we are subtracting 2 logarithms with the same base. So when we do that, we can divide their arguments. Don't forget the base 4 on that. So, don't forget, we're not done yet. We have to see if this can simplify more. So 48 divided by 3. That would be 16, so it'd be log base 4 of 16, which does simplify to just 2. I want you guys, see if you guys can do the next 2. Pause the video if you haven't. So, this third one here, we have logs with the same base. Okay, that's good. And we're adding them, so that means we can condense it, and we're going to be multiplying their arguments. Now, we're going to have 2 layers of parentheses, so I'm going to use a bracket for the first layer, 2x, parentheses for the second layer, and that's it. We just multiply their arguments together. And that fourth one, a little bit different than the other 4 we've been doing, but, so if we want to expand it, we bring the exponent out and put it out in front, but we are condensing it into 1 logarithm, so we're going to take what's out in front, we're multiplying, and that's now going to be the exponent. We're going to do that for both natural logs here, so that would be ln of x squared minus ln of y to the third. We're subtracting 2 logarithms with the same base, so that means we can divide their arguments and put all of this into 1 logarithm, which would be the natural log of x squared over y to the third. And you guys can put that in parentheses also, your argument in parentheses if you want to. And the last one, feel free to pause this and try the last one out for yourself. First thing I would do here, so let's see if you guys can do the first step. So pause the video if you haven't. The first thing I would do here is simplify what's in the parentheses. So if I'm going to simplify what's in the parentheses, I have logs, 2 logs with the same base. They're being added together, so I can multiply their arguments. So that would be 1/2 log base 3 of a times b minus, I'm not going to do anything yet here, you could, but I'm going to save that for the next step. So 3 log base 3 of c plus d. Alright, so now I have coefficients on each of my logs. I can write those as the exponents. So that'd be log base 3 of AB, and then you could write to the 1/2, but you're going to want to write it after that as a square root to completely condense it. So I'm just going to write it right now as the square root of AB minus log base 3 of C plus D to the third. I have two logarithms with the same base. They're being subtracted. So I can now divide their arguments. So it'll be log base 3 of radical AB over C plus D to the third. And you can put the argument in parentheses if you want to. That is the completely condensed logarithm. So, just what I want you guys to do next is do the success criteria. So there's 5 expansion logarithms and there's 5 condensing logarithms.